Let's go over some more of the problems from the first problem, first set of questions. Where did we leave off? We left off like we did. We finished the front page, right?
Yeah, that's
We didn't
what-
do L.
Please excuse the interruption. This is Mr. Geyser. I just wanted to address an issue that's been discussed this today quite a bit, and that's regarding our mask and the mask policy here in the district and at Columbia Falls High School. First of all, announcement I wanted to make early on is overall throughout this entire school year as a student body, you've done a great job in conforming to the policy. Obviously not everyone, but for the most part has done a good job. And I would just encourage, it's very important that we follow these policies and help each other out in that regard. Some confusion with the governor's announcement that about tomorrow. Understand that has no effect on schools. The mask policy is a school district 6 school board decision, and those policy was in place before any governor mandate, and they would continue to be in place until the school board would change those. So moving forward tomorrow, just like every day next week and proceeding, we still have our mask policy in place as we did at the beginning of the year. And that is masks should be covering noses, mouth, and whatnot for the entirety of a class period and throughout the hall. Hey, you've done a great job. Let's keep it up. Next week's Bleed Blue Week, and enjoy the sunshine. Have a great day.
Enjoy the
And
sunshine.
we'll see you tomorrow.
Did you just say enjoy?
Mask up, ready to go.
I'm enjoying it. I'm enjoying the sunshine. You don't enjoy the sunshine, Julia?
I can't enjoy the sunshine unless I'm outside in the sunshine.
I don't like the freezing cold.
Yes, it doesn't make any sense. Except enjoy the
Okay. So when you have that, this one is a really interesting result, actually. So you might, say you're having some trouble getting started on these. The other class, that was a few of them, that was their feedback. Is once I understand the steps, once I see them, but it's challenging to get started. What do I do as my first step, especially? So when you look at that, you might go, well, I do know that I've got this property that I can work with. X to a power divided by x to a different power would give me a subtraction of the exponents, right? We all know that one. So that might tip you off to how this one, you're like, well, I need to write them as exponents, which then leads you to your other property, which is, the nth root of x is the same as x to the 1/nth power. So this first one would be x to the 1/2 power. This guy would be x to the 1/3 power. And then let's use that property of subtracting the exponents. So it's going to be x to the 1/2 minus 1/3 power. Now I got to bring out the big guns to subtract two fractions.
That's impossible.
It's impossible. Just give up. Just
Right.
Just throw your paper in the trash can. It's not worth it. Flip the table over. Yep. No, we can do it. We go, okay. So 1/2 minus 1/3. Get those common denominators by multiplying the 1/3 by 2/2 and the 1/2 by 3/3. It's 3/6 minus 2/6. So 3 bananas minus 2 bananas.
One
Make a
banana.
1 banana. So our 1/6 is the answer to what the exponent is. So it turns out, I think pretty remarkably, that the square root of a number divided by its cube root is really just the 6th root of that number. It's pretty neato burrito. Did you lose your problem set, AJ?
Eddie is copying the first page since you lost the first page.
What's up?
Because I did it.
See it second grade.
So like we're in calculus or?
Yeah.
So like for one, they might, might just give you a problem where you take, there's things in calculus. The main focus of studying calculus is derivatives and integrals. These two like mathematical sort of, basically they're two math ideas, they're two processes, but like you might end up with this as your answer, or one way, a time you might see it is like, so a sixth root function looks like this. So if you have some quantity that was growing over time, but the rate at which it was growing was decreasing, so it's growing slower, more, it's always growing, but it's growing more slowly and slowly over time, it might turn out that that growth process can be modeled by a sixth root function that could possibly come up. The reason I'm covering in this class is a pre-calculus class is that when you take calculus, you deal with these sort of fraction exponents all the time. They come up super often. And so if you don't know how to like handle them algebraically, it just makes learning calculus extremely difficult. Okay, so let's move on. I don't know if we need to do every single problem from this page, but together. We can if you really want
We
to.
definitely do.
No.
Would that make you happy, Taylor?
I'm just kidding.
Well, we'll do the first one. M. So we got to address a couple of misconceptions first, which is, one, we talked about this before, but is that 8 being raised
No.
to that power?
No, just the X's.
Just the X. So the first thing you would do is you'd utilize the fact that negative exponents have to be dealt with, and they can be dealt with in this way. Like if you have x to the negative n power, that's the same as 1 over x n power. So that's a property that comes up quite a bit. So here you'd say, well, really, I'm going to think of that as 8 over x to the positive 3x. So we're okay with that? And then we also know that generally, if you have x to say the a over b power, that's like saying the bth root of x to the a. It's a bth root. Right? We're all cool with that, right? This, now here's the thing, there's nothing really wrong with this. There's really nothing wrong with this either, but there are certain contexts in which you want to have no fraction exponents or no negative exponents. So anyway, this would be 8 over the square root of x cubed. Okay. Do we feel okay about that?
Yes.
Can you do R really quick? Because I'm not sure what's wrong with it.
We'll get there pretty soon.
Oh,
You're
we're
a
not
little-
just jumping around.
Well,
No.
Sorry. I don't
Good,
know. I'm not
good.
really looking at random ones.
did you get P and Q?
Yeah. Yeah.
You sure?
No.
No, just P is one. P is kind of an infamous one because it's tricky. People very often get it wrong.
Then we probably
And
we do our P
we're
and
gonna go
R.
over it. We're gonna go over it. Don't worry. So P. Let's just jump to P. So N and O are very much like this. You treat them in almost the exact same way. P. Yeah, this one is like full of landmines as far as like. There's a lot you could do wrong in this, and I will resist the urge to talk for a million years about all the different wrong things you could do here. I'll mention one, can't help myself. One wrong thing to do is just to cross out that and that. Now here's the thing, why can't you do that?
Addition.
The addition on the denominator.
Yeah. So the additions in the denominator, I'll give you a simple example why that's not valid. I mean, if you had 5 divided by 5 plus 2, okay, that's 5/7, right? So that's equal to 5/7, obviously. Can you just cross the 5s out and have that be in any way meaningful? No. Okay, so what you can do is if you have 5 divided by 5 times 2, then you can do this. you get 1/2, right? But that's because you're not just crossing things out. What you're really doing is you're saying I can divide the top and the bottom by 5. It's a fraction, and I can multiply the top and bottom by the same number, or divide the top and bottom by the same number. So yeah, that's leading here to this. The way I would approach this is I would say I'm going to multiply the top and bottom by an expression that's going to get rid of all the negative exponents. Who's got an idea? Yeah, why can't you just flip it over?
Yeah.
Well, ooh, 'cause that's violating a lot of stuff.
X plus X plus
I'll give you that's a good question. Suppose you had, I'm gonna do it with, because these are basically fractions, right? Isn't that like 1 over x cubed? And that's 1 over x cubed, and that's 1 over x squared. So what if you had like 1/5 divided by 1/5 plus 1/3? Just making up numbers. Did you get the connection?
Yeah.
Can you just turn this into, can I just go, flip it over and go 5 plus 3 over 5?
Yeah.
No, no, definitely not, right?
What if
Right,
we
you-
really want to?
Well, do you agree with me that would not be okay?
It'd be a answer though. So-
It's certainly an answer, yeah. So the idea, so what you're probably thinking of is, yeah, if you had x to the -3 over x to the -5 times y to the -4, if it's multiplication there,
So we don't even flip.
that all comes down to like, because this really, now it's all multiplication. So what you're really doing when you when you move the y to the top,
You flip it.
what you're really, well, in practice, that's probably what, yeah, it's what it looks like. But if you think about what you're actually doing is this guy is 1 over y to the 4th, and you're technically multiplying the top and bottom of your fraction by y to the 4th, giving you 1 on top and knocking out the 1 on bottom. So anyway, I'm going to show you, here's a good technique, okay? You look at this. This is a technique that comes up a lot of times. You're dealing with a fraction that has a whole bunch of x's in it, especially if there's fractions within your fractions. You ask yourself, what could I multiply the top and bottom by that would get rid of all the things that are making me sad and cry? Very good. I multiply by x cubed over x cubed. Let's watch what happens. Let's go. Now we know how to multiply fractions, right? You got top times top, bottom times bottom. So what do you get when you multiply that and that?
-9.
You get x to the, we add the exponents, right?
Oh, 0.
X to the 0. And down here, that times that gives you the 0. Okay? That times that gives you x to the 0.
Yeah.
How about that times that?
X.
X to the 1. Right?
Yeah.
Because you're adding the exponents. But wait,
There's more.
what's x to the 0 power? 1. There's your answer.
1 over 1 plus X, yes.
That's what we got in the first place.
Ooh, nice job. Oh, she's
You
lying.
got it, Sean, right?
Oh, you fooled me.
Yeah, that's what we got though.
So Rita.
We had 1 plus 1 over X.
Yeah.
We knew we did it.
Yeah.
Solids are is cute.
1 plus 1 over x?
Yeah.
It's close, because 1 plus 1 over x is x plus 1 over x. So not quite.
We
Yeah.
flipped it.
Yeah, I mean, no one ever claimed that these properties are super easy to understand all at once, right? Like, I certainly get why you might think you can just flip it, but because of that plus sign, it doesn't quite work that way. Yes.
So are we supposed to be able to like intuitively figure these out? Because I feel like people are shouting out their answers like that's close, that's close. Like, I've got no idea what's going on. You did it out of the board. I know what to do now. I can solve that problem, but I probably can't solve the next one. So like,
There's just too
Yeah.
many rules to think about.
Well,
like,
it's,
I could solve M and I can do N. I can't do O. I don't know what's going on with O. There's something new added.
we'll do O. We can do O.
Then we should do Q because
I mean, it's, what it really is there's a set of properties that are all true on their own, and it's all about just how do I use them in conjunction with each other to modify these things to write them simpler. So yeah, it's not like say, okay, what's an example? Like quadratic formula. It's a very cut and dry procedure. You arrange you arrange it into this form, you plug those three numbers into the formula, you're done every time. This is much more challenging because you're like, well, if we write out every single property, there's maybe, I don't know, 7 or 8 properties. And it's not entirely obvious at any point which one should I use. So it's something you just kind of get better at through practice. I mean, it's all like, I know you're like chess, it's a lot like chess in that way. Like there's all these different ideas, and what makes it interesting is we're trying to figure out which one can I apply in this scenario that might like lead to something. So we can do O. So O would be like, you have 20 divided by 4 to the negative 3/4 power. So if you were writing like an algorithm of how to deal with these, your first step might be like deal with any negative exponents. That could be like maybe one of the first things you look at. Granted, if there's parentheses, maybe that's your first thing. So you gotta have something in mind of like, I see a negative exponent. Let's tackle that first. Okay. What is going to happen to this guy? He is going to move. He's moving to the top. Again, if you want to get technical, what's really happening is we are multiplying the top and the bottom of the fraction by this quantity. It effectively knocks him out, and we're left with that on top, right? Is everyone okay going from here to here?
Yeah.
Okay. So now, can I go 20 divided by 4?
Yeah.
Yes, because that's multiplication. If that was a plus, you'd have to be like, both of these guys are getting divided, so it would be a little more complicated. But with multiplication, you get 5, so 20 divided by 4 is 5. And how do I deal with this guy now?
Turn to that thing.
So the 4 tells us the root. It's the 4th root of x cubed. Cool beans?
Yeah.
Yeah, so
Oh my God, we did one
why
right.
can't you just divide the 20 by 4?
Um,
Right, but then,
Because it gets into, I mean, have you ever heard of Bertrand Russell?
no.
He was a philosopher. He wrote this book called it's called the Principia. I'm gonna be mixing up because Newton wrote the Principia, and then Bertrand Russell wrote. Oh my God, I'm blanking. Anyway, it's like this whole book that tries to establish that like stuff like 1 + 1 = 2, and like how every number has one number bigger than it, every natural number. So anyway, but to really get into like, okay, so say you had 3 times 8 divided by 3. Why can you just cross the 3's out? Well, it's
and it's
because
fun.
it's because division is the inverse of multiplication. So if you can think of this as going like, and also multiplication is commutative. So you can say, well, this top is like saying take 8, multiply it by 3, and then divide the result by 3. So take 8, make 3 copies, and then divide by 3,
Order of operation.
and you get 8.
Okay.
And so, anyway, yeah, I think it's very interesting stuff. You really get into, there's a lot of really basic math results that if you start thinking hard about them, you start to go, wait a second, why is that true? Why? Even the distributive property, I mean, that's one that's worth looking at. Like, why can you, so if you have 3 times 4 plus 6, why is it the same as 3 times 4 plus 3 times 6? You can confirm it's true, but why does that always work? It's kind of, you have to, what's really weird, and it all relies on the fact that like stuff like 3 times 4 and 4 times 3 are the same thing, which also isn't obvious. Because if you start multiplying other entities like matrices, you can't just flip them. It's non-commutative. There's lots of things in math that sometimes we take for granted with numbers that, and you can change the order of things and not affect it. But anyway, Sorry, rambling. But in any case, my advice, if you're having any trouble with like, does this thing I'm about to do make sense with the x's? See if it makes sense with numbers, right? Set up a comparable thing with numbers and just ask, could I do this? And often you'll see intuitively, you'll like be like, oh wait, I can't do that, or I can. Let's look at we're almost there, Cheyenne. We'll do R shortly, but Q. I would, does anyone have an answer to this that they feel somewhat confident?
Two.
Yes.
Two?
X, yeah.
Two. No, no.
Plus two.
X squared
squared
plus
plus two.
X squared plus X.
We got the two.
So what was your first step on this, Alethea, then?
Multiply it by X to the 3 halves over X to the 3 halves.
Oh, good. That's good. That works.
Yeah.
Yeah, so multiply by x to the 3 halves over x to the 3 halves. So let's multiply this by this. So the exponents do what?
Add.
They add up. So half plus 3 halves makes 2. Then multiply these guys. You get x to the first power. And then on bottom, you get x to the 0 power. And this is just, this right here is the number 1. So you can write this as x squared plus x. Does that seem fine? Could we also have split this up into 2? Yeah.
I mean, you can, but I don't know how.
Well, let's see. I'll show you. So back to numbers. If I have 6 plus 10 divided by 2, is it okay to go 6 divided by 2 plus 10 divided by 2? Is that valid? Yes, it is. That's valid. So here, by the same kind of logic, I could say x to the 1/2 over x to the negative 3 halves plus x to the negative 1/2 over x to the negative 3 halves. And then use that property of subtracting exponents. What's 1/2 minus negative 3 halves? Gotta be careful there, but 1/2 minus negative 3 halves is 2. And negative 1/2 minus negative 3 halves is 1. Is that a yeah? With the Macarena? The Macarena of
You
times.
missed
That's
this
Mikia's
step. You
favorite.
missed this step.
Oh, I'm sorry. Yeah, no, elbow stab.
Did I get it right?
Yes.
I get the renegade now.
There's no.
You failure.
Wait, there's no elbow? You don't go like that.
I always thought
No,
we did.
go
No, you just go to the shoulder.
shoulder. Stretch shoulder and then head. There's no elbow.
No elbow.
I believe in
Julia, who taught us wrong then?
Normalize the elbow.
Normalize
No.
elbow step.
No.
Okay.
But it throws off the song. And you guys not done it to the song. Understandable.
Right. Sending in this kind of question. Could you multiply the top and bottom by something to make it work?
I don't know. I tried. I tried.
I think, to me, in my opinion, I'd split up. What'd you say, Alyssa?
I was just wondering if you could do it by square root of x.
Yeah, that's one way. You can multiply by root x over root x. It's a slightly indirect approach, but it'll work. It'll maybe take like one extra step, maybe, but it's fine. Let's try that. So you go, what's root x times root x?
X.
X. And then x to the 1 times x to the 1/2. Or actually, you know what might work is just to write it like this. Because I'm looking a little bit ahead. I'm thinking like a step ahead and going I know how the bottom's going to be what?
X.
X. Now do you see I've got,
You can cancel.
they're both going to get divided by x. So that divided by x. So if I'm showing my intermediate step here,
One.
That was the appropriate response.
right? I can split this up into 2 and I get 1 minus root x.
You can cancel. And then denominator, no cancel.
Are we yes there? Are we
Yeah.
yes all around?
No, no, yes.
We're not yeah.
What would be your direct approach?
You just like
Probably just to
think about it.
go straight from. So I look at that and I go, well, the addition's on top, so I can just split it up right off the bat, right? And then depending on how comfortable you are with your mental math, like this is obviously one, but like this guy, you might draw it one or two more steps, but I'd probably look at that and go, well, it's x to the 1 over x to the 1/2, which makes x to the 1/2, which I know is the square root of x.
X squared bigly.
Or you think of x as root x times root x and cancel one of them. It's the spice of life. Let's keep going.
Left it X squared.
S for streaks. Did you guys all send your streaks today?
Nope. Forgot.
Snaps. No streaks.
No streaks.
Streaks are no longer in vogue.
Sean.
Rita, can you weigh in on this?
I don't really like texting people or like Snapchatting people. Like unless I
What do you mean?
have to.
I've never seen you once not looking at your phone.
It's
No,
TikTok.
it's all TikToks.
No,
It's all
just
TikToks. Okay, I'm sorry.
Well, like
Well,
if I have
streaks
something
are
to say to someone, but
acceptable
it's
if
just
you're
like,
actually having a
hey,
conversation.
how are you? Like, why would you text someone that?
Yeah, that's the difference.
I don't know the answer. I'm on a constant journey to understand things.
Because
Yeah.
some people just want to slide into the DMs, so that's what they do. They're like, hey, how are you? Like,
Oh, okay.
I will.
I always, the best way to open your DMs is go,
Oh,
I'm 1,000 elo on chess.com. It gets them every time.
Oh, okay. That's your.
But instantly.
Yeah, it seems.
But I thought that streaks weren't sneaking into the DMs. I thought that was just you sent the streaks or something every
some
day.
people send streaks in order to be able to start a conversation.
Oh man.
Dumb.
Okay. You guys think math is complicated? This is easy. Comparison to understanding the world. Okay. Let's look at this and go, well, what should be maybe our first step? Maybe think of your dear Aunt Sally.
Parentheses.
Almost.
Yeah. Order of operations says that parentheses goes first, and so I might go, I can't combine those, but I could square it and then have it kind of expanded. So if I square this, I get
X fourth plus 2x to the third plus x to the second.
all right. So we're okay with how I got from there to there? You okay?
Yeah.
Right?
It only took me 5
And
minutes
then
to do that for myself.
No, divide.
Now, yes, you might go, now again, look out for those mistakes of like, it's tempting to do that, but they're all divided by
Do it
x squared.
everywhere.
So that guy divided by x squared makes
X
Squared.
x squared. That guy divided by x squared makes
2x, 2
just 2x.
plus
That guy
1.
makes a 1.
We got the same
Oh,
answer,
plus
but we did
one.
it differently.
No.
Now,
We
can you make it
multiplied by
to
x to the negative.
factors of 1
Now
and
you can
2?
find
X plus 1 times x plus 1. X plus 1 squared.
We did that, and then we did times x to negative 2.
There you go. That's great.
Do you want us to?
Is x plus 1 is simple. X plus
could.
1 squared is simpler. But it's most simplified.
I like what Alyssa said. That's smart because I mean
Most
that
simplified.
seems like an easy I mean you're certainly using fewer symbols, but that's fine too. They're both fine.
No. Only the most smallest.
And yeah, there's other ways to do this, guys. I mean, let me show you one more way. It would have been to go straight from here to here. You could have factored out an x from here, like x times x plus 1. It's still squared.
I don't like
I
that.
hate that so
Okay,
much.
but then now both of these things get squared, so you'd have x squared times x plus 1 squared.
And then cancel Eva Vansley.
Cancel Vansily, you got the final answer. That's I mean, that's gone kind of a weird way of going about it, but it's valid. Let's look at T.
I don't like that one.
Let's spill the tea. Am I right, guys? That's good. That's a good meme, right?
I don't care if the way I did it is correct or not. I like the way it worked and not.
It was on the board when we walked in, so I just wrote it down.
Oh,
Good job, Nikita.
big brain.
Can you explain it? Help us understand. Oh, great, Nikita.
Okay, so that x is also x to the first, and you can change the x square root of x to x to the 1/2.
Good.
And then you can add those together,
Add the exponents now.
and then you can do that all times 2 to the 7th.
Hold on,
And
you're ahead of me here. So then, everyone okay with her first 2 steps? Yes? And then what do we do with those exponents?
add them, or
Multiply.
multiply them, yes.
So 3/2 times 7 is 21/2.
And then you can simplify it because 20 over 2 is 10,
That's the
so you
10
break
one.
it down into 10, x to the 10th plus, or times x to the 1/2.
Root out.
Yeah, so let's first look at this. This one's a little weird, right? This one threw the other class off quite a bit. Because it's 21/2. Now here's the thing. Could I write that as the square root of x to the 21?
Yes.
You certainly have a strong argument for that being written as that, as like the most simplified way, but a lot of times what we're looking for is, you guys remember like back in like, a lot of it's in geometry, algebra 2, where you do stuff like, oh, I got the square root of like 50x to the 9th. And you try to end up with that being like 5x to the 4th times the square root of 2x. Does that ring a bell to anyone? Okay. So it's like putting it in the simplest radical form. So anyway, does everyone understand how this is 10.5, 10 plus a half? So I can break it up into 10 and.
Oh.
And banana, makes sense?
Yeah.
You sure, Hamilton? Look like you're spacing out there a little bit. So you get x to the 10th times the square root of x.
You could do that with eight.
There you go.
It just looks like
Oh, mango.
We do?
So you can't distribute.
Let's look at U.
Freeze, rip.
Track that U.
Everyone just mumbles Brady.
Slightly, you.
It seems like a couple too many, but we got the spirit.
There's actually
Okay, long ago, captured Sumer section 12. View.
All right.
Mr. Bergen.
Oh, you can flip all the.
I don't like it. I'm like it. I'm not-
action.
No, why is it?
Those parentheses are all the actions and you.
Yeah, I'm just gonna say that.
So there's a few ways you could approach this one. You could say it's a thing minus a thing divided by a thing, so you can split it up into 2 divisions, right? So I could have x, I have x to the 4th divided by x to the negative 4th. That's not 1.
It's negative.
Minus y to the negative 4 over x to the negative 4.
Oh,
Does
it's
everyone
X to
understand
the 8th.
It's
that first thing there?
That's X to the 8th.
You sure?
4 minus
Yes.
negative 4.
Okay. Now this guy, you can think of, he'd be like, I'm negative, I have a negative exponent and I'm on bottom, so I can travel to the top. So what am I gonna have here?
X to the 8th.
It's the
X to the 8th
And then
power.
can you flip the other one?
Yeah, this one, you go, he's gonna jump to the top, and
Yes.
that guy's gonna jump to the bottom, so you're gonna have an x to the fourth over.
Ooh.
It's a game of leapfrog with math.
Leapfrog.
Limp.
Leap and lemurs.
Where's the
Hey, Taylor?
sponsor?
Wrong.
Funny you have.
Paul, do you
No.
have a sponsor for
Aiden?
this today's episode of Calculus?
Number what?
Do you have a sponsor for today?
Aiden.
No, it's Raid Shadow Legends.
Raid Shadow Legends? What is that?
Oh, a bunch of YouTubers got sponsored by this like
Online game.
dungeon card game that's essentially where you just get a bunch of heroes and go loot dungeons. And everyone was sponsored by it. Yeah,
Okay.
it was
It was kind of a meme that
it was
everyone was sponsored by.
yeah.
Oh, it's a meme. Oh.
Runebix too.
Memes have reached the apotheosis of meme.
Runebix.
That's a big word.
Meme? I know. Pretty savage, huh?
Yes.
Yeah. Let's should we do W? No, Julia? Why not?
I'm gonna try to figure it out.
Okay, yeah, go for it.
6:15.
I've covered quite a few. I think I'll end the video for this time. Thanks for the 100 gifted subs.